On the homework, I believe you have a frame beam example. A frame beam problem. So I'd like to run a frame beam example for you in case you would like to follow along and know better how to do that. What I've drawn here on the left, I've pre-drawn the frame beam connection. So you've got a wide flange column. We don't have a specific size. That's not as important. But we do have a W21 by 57 beam that's coming horizontally and attaching there. And what we want to do is size the clip angle that would fit in here. And by size it, we're looking for what that maximum length is that will fit in there so that we can determine how big a clip that we need to carry the load in there. One thing that I would like you to note is that we typically consider a 1-inch gap on the top and the bottom, 1-inch clear space. This is simply so you can account for any of the curvature that may be in there, and this will give it sufficient room to fit. Also note, we are going to use A325, which are your high strength bolts. SC is the hole type, and these bolts will be 3/4 inches in diameter. That little symbol right there on the end is the symbol for diameter. And so 3/4 inch diameter bolts. All right, determining here the length of the clip angle. That's our Lmax that I've determined in there. Technically, we're finding Lmax and then finding a clip angle that works. And then we'll use table 10.3 to find the number of corresponding bolts that fit in that clip angle and therefore what the max allowable shear capacity is. So first thing we want to do is find the length of the clip angle. So to do this, we need to essentially use the geometry of the wide flange section. And so we're going to go to appendix table A3, and for a W21 by 57, if you go back to that appendix, you'll see that it has an overall depth of 21.06 inches and a thickness of the flange of 0.650 inches. And again, that was from appendix table A3. All right. The math is pretty straightforward here. What we need to do is just start subtracting out the geometric dimensions that aren't usable with our space. So we start with the overall length, and we want to minus 2 of the flange sections. We have a flange on top and a flange on bottom, so there's 2 of those. And then we want to account for the 1-inch clear space on both sides. Oops. Clear space. We'll make sure and label these here. Thickness. This is the height of the total beam there. Run that math through your calculator, and we have 17.76 inches of space available for us. All right. Next thing we want to do is jump in our textbook where they give us the dimensions and load, capacity, the bolts, etc. for a frame beam connection. And so from table L3, you'll note that there are 2 different lengths shown. There's an L column and an L prime column. The L column shows the clip lengths for standard alignment. This means that the holes on each side of the clip line up, and the L prime column is for a staggered alignment. And that simply means that the holes on each side of the clip, as you alternate back and forth, stagger back and forth. So the largest clip size given within that table, when we're looking at the L column, you'll notice that there is a 17.5 inch clip angle. That is the biggest one that fits within those tolerances we have. So 17.5 inch, whoops. Again, that's looking at the standard column. So if a 17.5 inch clip angle fits, what does that do for the number of bolts and the capacity that then results from this frame beam connection? Again, we're still in table 10.3. We actually stay along that same row for the 17.5 inch standard clip length. And you'll notice that the next column over says N. This is the column after the L prime. N column is the number of bolts. So N equals 6. We would need 6 bolts. Again, the assumption was these were A325 SC bolts. And so we jump over there, 3/4 inch diameter, same column, and you'll see that the capacity is 90.1 kips. This means that if we have a framed beam connection where we have 6 bolts on each side of the frame clip, A325 SC bolts, 3/4 inch diameter, and our clip length is 17.5 inches long, then we would be able to carry or transfer a load capacity of 90.1 kips from the beam to the column. So long as our load being transferred is less than that, this connection should be good.